Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at a practical application for solving a system of equations. So why don't we go ahead and get started here. So here's our problem. Tom, let's see here, what's his name? Tom has two options for his salary as a salesman. Option one pays him $50,000 plus $30 for each item sold. So this is a high commission job, obviously. Option two would pay him $20,000, per year plus $80 for each item sold. How many items would Tom have to sell in order for each salary to be equal? So what's happening here basically is that we want to know, just as an example here, this is my graph, if you will, my coordinates, whatever you want to call those. We want to know, where do these two lines intersect? We're looking for that magic spot right here. That's what we're looking for. And so what we're going to do now is we're going to solve this. And so we're going to pull it apart piece by piece. So we want to know salary. And we know that there are two equations here because we clearly have $50,000 plus $30, $20,000 plus $80. It's clear that there are two separate equations happening here. 50,000 plus 30x, or 30n, or whatever you want to call it, 20,000 plus 80x, whatever you want the variable to be. So what we're trying to figure out here is salary. So we're going to call that S. And remember, we have two equations. Equals, for the first one is 50,000. This is what you start with no matter what you sell, plus however many items you sell, 30. Now right now we don't know how many items we're going to sell. So right now we're going to just call that N because we're going to have a number there. N just kind of stands for number. And then for the second one, it's 20,000. That's the base salary no matter how well you do. Plus, let's see here, 80 times N, because we don't know how many items we're going to sell yet. And we want these two to equal each other. So we could try many different things. We could try elimination, but that would be kind of funny because we don't have any numbers that kind of factor out or that round out to even nice neat numbers here, unless you multiply by a decimal or something. So we could try graphing, but that's not the most exciting one. So we're probably going to do substitution, because if you look closely, you can clearly see that these two equations, they equal each other because they both have the same variable off to the left. So if we rewrote this, we could put it as follows: 50,000 plus 30n equals 20,000 plus 80n. Very clear, because remember, since S equals both things, if you put them both in the equation like this and you set up the expression like this, you're good to go. And so now you can just follow all the steps that we normally do when we're trying to deal with an equation. So first I'll subtract 30n from this side. And that leaves me with 50,000 equals 20,000. 20,000 plus 50n to be expected. And now I'll subtract 20,000 from over here and subtract 20,000 from over here, and I'll be left with, I guess I need a little bit more space here. Let me go to the next screen. I'll be left with 30,000 equals 50n, like so. Then I divide both sides by 50. And then my final answer is going to be something along the lines of this: 600 equals N. In other words, in order for the two salaries to equal each other, I must sell at least 600 items. After that, you might begin to see a difference where one pays more than the other. But this is the minimum. So no matter which salary I pick, it doesn't really start to make a huge difference until I get to 600. That's when they equal each other. Of course, you might get a head start with one of the other sellers, but that was not the purpose of the question. And so you can see here that, this is how you address a word problem, a practical real life setting where you're trying to find out the intersection between, two lines, if you will. That's kind of what's happening here. So this is a system of equations where we use substitution in a practical context. So just to recap, what we did here was that we looked at the word problem and we pulled it apart and we realized that we had two different equations. And again, the secret to knowing that was by looking at how you can clearly see two expressions right here in the actual word problem. We set up the word problem right here like so. And then we said, well, since S equals this and S equals that, that means these two equations equal each other. And from there, we just solved the basic equation that we've done many times before in the past. So I hope this was useful for you and that you were able to understand how we approach solving a system of equations through a practical application with the strategy of substitution. So my name is Darren Thomas. I am the Director of Educational Research Techniques. I want to thank you for watching. Take care.